Hey everyone, I am Yiming, and our project is about using Bayesian inference on cable stay bridge stack deformation assessment. And here I'm gonna introduce the first part of our project. So the first section is the introduction. Nowadays, cable stay bridge is a common bridge structure which has been widely used in the bridge design. So here we're gonna discuss one of the structure health problem, the bridge stack deformation. As you can see in the picture, this is the deformation damage on a cable stayed bridge. And this damage can be caused by many factors, like loading on the deck, settlements of piles, creep of concrete, and so forth. So in this project, we are trying to do an assessment on the deformation damage on the cable stay bridge. And this is all based on the monitoring system, which measures the temperature and strain for the cables. The real construction case we used in the project is the Adige Bridge in Trento, Italy. The total length of the bridge is 260 meters, and the bridge deck has a steel concrete structure. And there is one mast in the middle and 6 cables on each side. Since the symmetry of the structure, we just use 6 cables on one side. And here is the monitoring system. There are strain and temperature sensors for each cable, and the sensor used is fiber optic sensor, which we call FOS. Okay, next is about the dataset description. Here we just plot the raw data collected from the cable STR1TN. And the time history is from March the 11th, 2011 to July the 1st, 2012. Okay, for the next part, we did the preprocessing part for the raw data. Since the dataset is big and the preprocessing progress can simplify the following analysis. So here we picked up one data each day, and the data is measured at around 5 a.m., just before the sunrise. Because thus we can avoid a different weather impact on the temperature condition, and the temperature before sunrise also can be seen as uniform. So we just pick up the one around 5 a.m. And the next section is about the methodology. Our idea is to use Bayesian inference to analyze the data. So the approach guideline is shown here. First, we get the data, and then we assume the prior information, and after the Bayesian inference, we can get posterior information, and then we can have our assessment. To achieve that goal, the first thing we want to do is to create a statistic model. The one we chose here is a Gaussian model. As you can see in this equation here, epsilon represents the strain of a cable and epsilon 0 is the initial strain, and alpha is the coefficient of thermal expansion. Capital T represents the temperature, M represents the trend coefficient, and T is the time. Okay, and in the below equation is the system noise. So the assumption is that the elongation of the cable is influenced by two main factors. One is the temperature, alpha by capital T here in this equation, and the other one is the deformation, M by T. And the prior state theta contains the epsilon 0, alpha, and M. So after building the model, we move on to assume the prior condition. Altogether 4 variables here. For alpha, we just search the coefficient of linear thermal expansion of steel online and get this value. And actually, the challenge is to get the m value. So here we create a physical model. As you can see in the figure on the right side, the black line is the initial state and the red one represents the deformation. And using geometric knowledge and the Gaussian model we have in the previous slide, we can simply get the two equations on the left. And finally, we can get this one, the expression of m. And after calculation, we can get a value of m, and here in the table on the right hand. So finally, we can use the assumptions we have to do the Bayesian inference. And what we get is the posterior distribution of the variable m. As you can see in these two figures, which is the m value for cable STR1TN and STR2TN. Although there is a decline in winter, the m value is increasing obviously in the following spring and summer, which will make the value of m times t larger. And this means the deformation is getting serious, so we need to consider about related maintenance actions. Okay, for the next, Ian will cover the rest part of our project. Thank you.